Hi students, this is the third lesson for the topic of further functions for the International Baccalaureate course, Analysis and Approaches. In this lesson, we're going to have a look at what happens when we graph the reciprocal of a function. So to graph the reciprocal of a function f of x, we graph y equals 1 over f of x. And here's some of the features of the graph. Any zeros will become vertical asymptotes because 1 divided by 0 tends to infinity. Any vertical asymptotes will become zeros. Local maxima become local minima and vice versa. And when f of x tends to 0, 1 on f of x tends to plus or minus infinity and vice versa. And finally, the sign of the y-coordinate doesn't change because 1 divided by a negative number is still a negative number. Now, we learned about sign diagrams in an earlier topic, and that can be really useful when you're sketching any function. Below is a sign diagram for a function f of x. Draw a sign diagram for the reciprocal function. So remember that asymptotes are going to become zeros, and zeros are going to become asymptotes. And everything else is going to stay the same, isn't it? Because 1 divided by a negative is a negative, and 1 divided by a positive is a positive, etc. So there's our sign diagram. Example 1, graph the reciprocal of y equals x minus 1 multiplied by x plus 2. So we start by locating the zeros because they will become vertical asymptotes. There's one, and here's the other one. Now we're going to look at this minimum. I know I said minimums become maximums, but not necessarily at the same y-coordinate. That y-coordinate there is approximately negative 2. 1 divided by negative 2 is negative a half. So it is going to be a maximum, but it's going to be up here. And it's going to turn around and then head off to negative infinity like that. Now let's have a look in here. I always start by locating y is equal to 1, because that doesn't change. Now, in between here and the x-axis, we're getting closer and closer to y is equal to 0. So the reciprocal is heading off to infinity. Here, we're heading to infinity, so 1 divided infinity, it tends towards 0. So we've actually created a horizontal asymptote. We have some symmetry here. It's going to be the same on the other side. And there's our graph. Let's do another one. Graph the reciprocal of the square root of x plus 1. So again, any zeros become asymptotes. And let's find the y-coordinate of 1. And then this graph tends off to infinity very slowly, but it does. And so on this side, this is going to tend, let's do that again. This is going to tend towards 0, so we have an asymptote there at y is equal to 0. And then this is going to head off to positive infinity. Example 3. On the same set of axes, graph the reciprocal of the function shown. Right, so we've got zeros here and here. And we have a maximum. This time the y-coordinate is 1, so that's nice. So let's just flip that up like that. Now, we have a horizontal asymptote at negative 3. So in the reciprocal, we're going to have a horizontal asymptote at negative a third, which is probably about here. When we look for y is equal to negative 1, that's there. So we're going to tend up that way and then tend down to infinity there. And then all we've got to do is this side of the graph here. Again, let's find 1, which is there. That's going to come down like that. Now this time when this flips around though, because this is heading towards negative infinity, that's going to head up towards the x-axis. So this is a funny looking graph. This has got like a split
horizontal asymptote, which in fact I might not draw it there. I might leave that there. So it kind of starts from 0. There's the asymptote that goes here. And then from 4 onwards, you have an asymptote here at y is equal to negative 1/3. Weird graph, hey? So let's have a little chat about domain and range. What is the effect on domain and range if we're sketching the reciprocal of a function? Range can be found through taking the reciprocal, and if you just plot a few points, you can see what's happening. But domain is tricky. If the range includes zeros, so if it cuts through the x-axis, you're not going to be able to determine the domain. Let's start with a straightforward example. Suppose f of x has a domain of -2 is less than x is less than 5, and a range of 2 is less than y is less than 4. So we'll start by drawing up a possible curve. Now you can see that if I take the reciprocal of that function, the domain isn't actually going to change, but the range is. If we look at the extremes, this is a y-coordinate of 2, the reciprocal is a half. This is a y-coordinate of 4, the reciprocal is a quarter. So the range is going to become a quarter is less than y is less than a half. Now let's look at a harder example. Suppose f of x has the same domain, -2 is less than x is less than 5, but this time it has a range that includes y is equal to 0, the x-axis. Let's draw up a possible curve. We can again look at the extremities. So here we've got -2, that's going to become -1/2, and here we have got 4, so that's going to become a quarter, which is probably about there. But the problem is we have an asymptote here, and so we're going to get some behaviour that tends towards plus or minus infinity. In fact, it's going to look something like this. This is going to become a maximum there, and we've got a minimum somewhere around here, I don't know. Something like that. And in fact, if you look at the range, the only place that it doesn't exist is in the centre here, in between -1/2 and a quarter. So our range is going to be y is less than -1/2, y is greater than a quarter. Now when we're talking about domain, it's because of these zeros that we can't actually determine the domain. This is going to cause a vertical asymptote, therefore it won't be included in the domain, so we need to know where it is. Furthermore, I could have drawn the graph like this. This one has 5 zeros. It's still in this domain and range, but those 5 zeros would cause 5 vertical asymptotes, 5 x values, which we need to exclude from the domain. So, domain will depend on how many zeros and their position. Therefore, we cannot determine the domain. Now, the reciprocal trig functions are really famous. And recall, the reciprocal of sine x is cosec x, the reciprocal of cos x is sec x, and the reciprocal of tan x is cot x. We're going to draw their graphs. So let's start with cosec x. Of course, it is equal to 1 over sine x. I'm going to use the same methods. Anywhere there's a 0 becomes an asymptote. Now we're a bit lucky here because those max and mins have got a y-coordinate of 1 and -1, so they're going to stay the same. And this graph's going to tend up like this, and then here it's going to go down like that. Now let's do the graph of sec x, which is 1 over cos. We have asymptotes here and here, and again our maxes and mins have got a y-coordinate of 1 or -1. So this one will tend up here. We have got a maximum here, and we've got part of a minimum here. And finally the graph of cot x. which is 1 over 10. So we've got asymptotes here, and here, and here. And at pi over 2, we have an asymptote for tan, so that's going to become a 0 and there. And then to figure out which way this orients itself, let's find the y-coordinate of 1, which is here, because that's going to stay the same. So this graph's coming down through here and off to negative infinity, and the same here, like that. Okay, that's it for this lesson. In our last lesson on this topic, we're going to look at the absolute value of a function and what it looks like when we graph that.